Hello, we're going to look at differential equations today, and the main feature of differential equations is effectively they are an equation which says dy by dx. That's why they're called differential equations. And there'll be something to do with dy by dx. It might just say dy by dx equals something. It might be a bit harder, and it might say dy by dx, I don't know, times by something like 3x dy by dx equals some other function. Sin x, for instance. And I'm not saying that I'd want to do that example. I'd certainly much prefer it if it just said dy by dx equals 5x squared and that was it. But you know, potentially these are the type of questions that we've got to be able to do. Now the main method for solving these is called separating the variables. So the method of separating the variables, and this is the separation of the wheat from the chaff, if you've ever heard of that expression. I'll let you look it up on Google. But this is separating the variables in order to solve differential equations then. Year 13, exercise 13a. So a couple of questions just to start us off. What's another way of writing 1 over cos squared? You should know that's sec squared. 1 over cos is sec, so 1 over cos squared is sec squared. And what do you get if you integrate this? This you might not remember. Now this of course is sec squared. What do you get if you integrate sec squared dx? I'll leave you to pause. I'm going to pause the video and just give you a chance just to remember that. Or look it up probably. Oh look, I'm hoping you have now looked it up. This equals tan x. Technically tan x plus a constant. But it's quite common to see this. You know, be asked how to integrate that, and you're meant to suss that. You first, let's put up the answer. That was sec squared. So you're first meant to say, 1 over cos squared is sec squared, and the integral of sec squared is tan plus a constant. Don't forget this. This is often worth a mark at the end of a question, so you don't want to lose that simple mark. And start number 2. Now this is what I was saying about. These are the simple ones, and when you do exercise 6a in a bit, you'll find a lot of them look like this. This is a pretty straightforward dy by dx equals some function. Now, first of all, I don't like that bracket, so I'm going to multiply it out. 6x minus 6x squared. That's fairly straightforward. Now, you'll notice it says dy by dx. And what I can think of doing here is that dx I can think of as moving over. And when I move it over, it becomes the integral of dy equals the integral of 6x minus 6x squared dx. You'll notice I can move the dx over to the other side and integrate at the same time. Now, this is technically the integral of 1 times by dy. So if I integrate 1, I get y. Another way to think about this is if I get rid of the dy by dx, it becomes a y. And if I integrate 6x, add a power, so that's 6x squared, so that becomes 3x squared when I divide by the 2. And divide by this time a 3, I reckon that'd be minus 2x cubed plus a constant. Now, but this constant is sometimes something that we want to find. This, I suppose, the posh name for this is the general solution. But there will be equations potentially later on where they ask for something called the particular solution. And the particular solution we're going to concentrate quite a lot on when we come to exercise 6b and the next video. But the general solution, let me just show you how we'll try to do it. This is obviously an x value, this is a y value. So I can chuck the y in as 4. So 4 equals, and it says 3x squared, so I'm going to write 3 times the 1 squared minus 2 times the 1 cubed plus a constant. And obviously, very often these are quite straightforward numbers. 3 minus 2 is 1, so I reckon C is 3. And therefore that gives me a final equation. Y equals 3x squared minus 2x cubed plus 3. And is that the answer? Yeah, interestingly I wrote it in a different order. I put the 3 first and went then the sort of lowest power first, I suppose. But I'm fine with that, I don't mind that. This is probably slightly neater. So anyway, I did say this is a new technique called separating variables. I've kind of hinted at that we've seen this before. So this is very much like the one we saw. Notice there's an x over here. So what I'm going to do is I'm going to just simply move the dx over. So that would give me dy equals x dx. But when I move it over, I integrate both sides. And essentially I put the x's together. That's the separating the variables. You put y's on one side, the x's on the other. Integrate 1, remember that I said just now that this is really 1 dy, becomes y equals, integrate x, I get x squared over 2. Don't forget my constant. Now this time it doesn't give me the initial conditions, it doesn't say and passes through the point 2, 4, something like this. And so therefore that's as good as I can get. That is my answer. The second example, well, one thing you'll notice is it says y on the right hand side. So if I move that over there, I've done what I said don't do. I've said put your y's on one side, your x's on the other. I'm still going to move it, but I'm going to move that one back again. So let's do this one by one. It becomes y dx. It becomes dy effectively over y equals dx. And at this stage we integrate both sides. Now, what I don't like about this is it doesn't really show what that is. Really, it's 1 over y dy. And that should start making you think. And this is really like 1 dx. So when you integrate a 1 over, that becomes a log, a natural log. And it says y, so it's log y equals, integrate that is x. And you might not want to leave the y there. You might want to, the log, sorry, there. You might want to move that over to the side. Move that natural log over, I get e to the x plus a constant. Technically, I suppose the constant comes there. And when, yeah, I've got to be a little bit careful. I nearly made a bad mistake there. When you do the integration, that's when the c appears. So if I now move that over, technically it's e to the x plus c. Like there, the plus c is up there. Now, because I can write that as e to the x times by e to the c, you should remember your power rules. And e to the c can be thought of as just another number. And if c is 2, it's e squared. If c is 4, it's e to the 4. It's just a number. Very often people write that as a e to the x. They move it to the front. They give it a different letter because it's really e to the c. And that's the equation. I haven't seen the answer, but I bet it's that. Y equals a e to the x, and just about make it out. So that's weird, isn't it? Here we've got plus c. This is really our constant of integration, but it's been transformed because it's had the log moved onto the other side. So a few more examples. We're going to do proper examples now, more complicated examples. And by complicated examples, I mean, look, there's y's and x's now. We don't just got one, we've got both. So let's go for it. Move the dx over there, and so they effectively switch places. It's the integral of 1 over y squared. Notice I've put it just on the bottom, dy equals the integral of cos x dx. Now this is like y to the minus 2. So when I add a power, I get y to the minus 1 over minus 1 equals cos, do you remember this? Sine cos minus cos. If I integrate cos, I get sine plus a constant. Notice this is really minus 1 over y to the minus 1 minus equals sine x plus a constant. Probably we don't really want it like that. I bet the answer doesn't write it quite like that. Here is the answer. Although they very nearly did. They just flipped upside down and put the minus on the other side. So notice they've just said, and there would have been other ways to write that as well. So they prefer to write it as minus 1 over. So effectively this switches places with all of that, and you get all of that on the bottom. Okay, fair enough. As I say, there are more than one way of writing that. Next couple here, examples 2, I've said. Notice I've got dy by dx, dy by dx. The first thing I want to do on this is take out dy by dx as a common factor. That would give me 1 plus x squared equals 2x. Well, fair enough. Now, notice what I've got to do. I've got to move the dx over there. That gives me dy on the left, and just dy actually, because these are just x's, I've just spotted that. And on this one I've got 2x over 1 plus x squared, because that kind of goes on the bottom when it moves over. The dx goes up to the top. But when I move them over, I integrate both sides. So remember, if you integrate 1 dy, you always get y. Now this one, look, I thought when I was just doing it, I thought, oh, that's going to get tricky, but actually it's not. Look, if I differentiate the bottom, remember, if you ever get a fraction, your first thought on the integration should be, does the bottom, when it's differentiated, equal the top? And the answer is yes, it does. It's exactly equal to it. I don't need to play around with it. So this is just going to be the log of the bottom plus a constant. Don't forget that constant. This is right. Again, I've got to rearrange it. Well, I think just move that over there. I'll get e to the y dy equals 1 dx. It becomes a times. Now notice I integrate both sides straight away. Integrate e to the y, you get e to the y. Integrate 1, you get, notice now because it's dx, it's x plus a constant. Again, I've got to move that e onto the other side. And this is the opposite of what we had before, because when that e moves over, I get a log, a natural log of x plus a constant. Yes, that's right. And log of 1 plus x squared plus c. Perfect. So find general solutions for these. Again, now these are written in implicit form, leaving the answers in implicit form as well. So implicit basically means it doesn't say y equals dy by dx equals. It just says leave it as you find it. So first things first, let's try to split this up to separate the variables. The dx is going to go over there. That will give me sine y dy equals cos x dx. And now once I've split them into two different parts, integrate sine. Remember what I said, sine cos minus cos. I think sine goes all the way up and round to minus cos. So I get minus cos y on the left hand side. And if I integrate cos, I get sine. So sine x plus a constant. Technically that's it. You might move the minus over. So if I make that a plus, I'll make that a minus. It doesn't matter about whether it's a plus or minus constant because we don't even know if it's positive or negative. Now this one is exactly the same idea. The one thing I don't like about it is the fact that it says y in two different places. So my first thought is factorize again. Well, I think I'll get x squared plus 1 is dy by the x. And I think now it's movable. That y is movable. So I'm going to switch those two round and I'll get dy over y. And I think I've shown you before, you write that as 1 over y equals the x squared plus 1, don't need the bracket now, and the dx. And I integrate both sides. Integral of 1 over y is log y equals integral of x squared plus 1, well that goes x cubed over 3 plus x. And it said leave it in implicit form, so I suspect that's what it's got. Log of y is that, yes, and minus, well they left the minus where it is, both are right. And this is possibly the last question I'll get onto, but let's just see how we go. We've got, this is the differential equation, we've got dy by the x equals this, and again, can I split that? Probably can. If I write dy by dx, and I write that as x, notice y minus 1 again, don't like that, then effectively the dy and the y minus 1, put that on the bottom like I'd shown you how to do, equals the x dx. Integrate both sides. So 1 over that, I reckon that's natural log again of y minus 1 equals x squared over 2 plus a constant. Now I've got to, you should be aware that I might not quite get this answer. Well, I might do it. Let's see. I think I might actually have enough. I've got to move the log over. It becomes an e. So I get y minus 1 equals e to the x squared over 2 times by a plus c, sorry. And that plus c can be split. That's what I was thinking of doing straight away. I can write y minus 1 equals e to the x squared over 2 plus or times by effectively e to the c. And that e to the c is like an a, e to the x squared over 2. And obviously the 1 moves over. And I think I've actually got it. That's the same thing as that. We've got one more question. I'm going to save that for class. We'll do that in lesson. And these are the questions we're going to do in lesson as well. So exercise 13a, we're going to touch on this. Might be a bit of a light touch. You see, I've suggested just doing question 1. But there's also a couple of questions in exercise 13b. And if there's more than that, then brilliant. Okay, we're just trying on these questions to have a look at the general solution. We'll look at the particular solutions properly next lesson.